Hey guys, I just wanted to explain this slide a little bit more. So this first equation here is what we've been using in class. This is like the just original exponential format of an equation. All right, where we have the output, the y-intercept initial value, the common ratio, and then our input, which happens to be the exponent. So right here now, what we're learning about today is called the compound interest, my handwriting sucks, formula, okay? So this is used a lot in finance and things like when you're buying a house or when you're trying to find the interest on a loan or things like that. We use the compound interest formula. What I want you to see here, though, is that it is basically just an exponential function. This A is still our output. The P is still the initial value. This whole green part is still our common ratio, and the T is still our input. However, let me make a little bit, well, no, I'll leave it on here. We have different names for them in math. So let me actually go to one more slide. All right, so when we have A equals P times 1 plus or minus R to the T power, new vocab for you. This stands for the amount. All right, and I'm gonna add, it's like the total amount at the end of the problem. All right, so that's like what we're gonna end up with. A lot of times it's how much money are we gonna have? Or what is your interest gonna be, right? That's the total amount at the end. This P stands for something called principal. All right, and principal really means, like we said before, the starting amount. All right, so that's why, it's the same thing as the y-intercept or the initial value. In a lot of financial problems, this will be like the cost of the house in the beginning or the cost of the car. In a population problem, this could be the starting population. All right. Like we talk about today, this plus is going to tell us that we have growth, right? If we have 1 plus something, our common ratio is going to be greater than 1, which means we have exponential growth. If it's a minus, we're going to have decay. 1 minus anything is going to be less than 1. If our common ratio is less than 1, we have exponential decay. And then this is going to be the rate. Okay? It's really important that the rate is always in decimal form. All right? So if in the problem they give you a percent, like it's going to appreciate at 7%, you have to change that 7% into decimal form. And then last but not least, the T stands for time. Usually when we're doing these kinds of problems, our input is time. So, how much is the house going to cost after 10 years? 10 would be my exponent. What is the bacteria population after 3 hours? Well, 3 would be my exponent because it's 3 hours. That's my time. All right, so just wanted to show you guys, these are the, words that we use to describe the interest formula, but it all relates back to that original exponential function.